All right, let's talk about one of the most critical connections inside any industrial heat exchanger.
These things are absolute workhorses, and their main job is to transfer heat between fluids. But everything, and I mean everything, hinges on one crucial point: the tube-to-tube sheet joint. This spot is where it all succeeds or where it can catastrophically fail. So how do you make that seal? Well, engineers basically have two main choices: expanding or welding. Expanded joints literally use force to create a friction fit. Just think of a cork in a bottle. It's a super common method, but it can be tricky to make and even harder to repair later on. Welding, on the other hand, offers incredible strength, but the catch? It's all about the quality of that weld. And for the really demanding jobs, you'll often see a hybrid of both for maximum security. But no matter which method you use, every single joint has to meet two non-negotiable requirements. It's got to have strength, and it absolutely cannot leak. It's a crucial balancing act. Say these joints have to transfer all the loads from the tubes, holding the whole thing together. And how leak-proof it needs to be, that totally depends on what's flowing through it. Okay, so let's zoom in a little closer on the specifics of designing these welded joints. A full-strength weld is exactly what it sounds like. It's so strong, the tube will fail before the weld does. This, for example, is a fillet weld, a common geometry used to get that full axial strength. Then you've got a partial strength weld. It's not weaker, just smarter, engineered for specific loads. And finally, the seal weld. Its only job is to add another layer of leak protection. It's not for strength. So you see, engineers have this whole toolkit of weld profiles to perfectly fit the design needs. So the choice isn't just about pure strength. It's about finding that sweet spot of smart, practical engineering.